All right, and we're live.
Welcome back, everyone, to the Op Show, where we bring you the trials and tribulations, the collaborations and automations from the world of DevOps and the greater developer experience. I'm your host, Tristan Pollock, as always, with CTO.ai founder Kyle Campbell. In our best show yet, we have Adam Dymitruk, where I heard there is no correct way to pronounce his last name.
That's right.
He's the author of Event Modeling, which is a really interesting mapping concept, which we are going to talk about deeply in this episode. And he's the original contributor, big open source advocate of CQRS and event sourcing. So excited to hear about your open source contributions and everything you do with the open source world. Finally, he's also the founder of Adaptech Group. Adaptech Group.
Yeah.
Thank you so much for coming, Adam, and really excited to have you here. We're going to get into some really interesting stuff on the modeling side. Welcome to the show.
Thank you for having me. It's really fun for me to talk about this stuff all the time because there's so much to talk about, and it's such a interesting history to me anyway about what's happened with the industry over the decades and how it influences what we do and what keeps us passionate and how we want to help out along the way.
Yeah, rumor is that you have a couple twice a week meetups that you go talking about event modeling for hours on end.
Yeah, it's really an event-driven meetup, so about event-driven architectures. So not just event modeling. That's our contribution to the work out there, but it's basically a meetup that people can. It's a bit ambitious. It's twice a week, 2 hours at a time, Mondays and Fridays. But I've always been someone that wanted to contribute to the community and help others, bring them up to understanding. So it's something that I wanted. I wanted a platform in the local community to be able to exercise certain skills and to be able to find answers for things that were only presented sporadically at different meetups. So I used to have to wait until some meetup, maybe a JavaScript meetup or some architecture meetup, which in person used to get, used to hold those maybe once a month. Some were even more rare. If you're lucky, they were every 2 weeks. And then you'd have to still wait for the topic of your interest to come up. And so if you're looking at a number of meetups, you might have 3 or 4 in a year that were really helpful. And well, that's just not fast enough to learn something. So then you'd have to look at, well, where can I get an education on this? Well, most of the stuff out there in universities and colleges isn't to the level of what's going on in the industry right now. That's sort of lagging. You could take, yeah, exactly. If you're at the leading, if you're at the bleeding edge of something and you're with the people that are moving things forward, there'll be very little out there for you as already produced works to work with. So
let's even take it back a second.
Sure.
Tell us a little bit about your background, how you got into and leading up to your journey, about how you got into event modeling and open sourcing, and take it forward from there up until your work today.
I'd also love if you could share a bit about how to think about event modeling. You shared something in the past, which I think is an important concept, to view the mental model of event modeling. And I think it was something like automating information systems, but I think helping people to understand how to shift the perspective around this concept, because it can be so universal and it's such a strong architectural model, and how you got there and how you think about it. I think that's a great premise for us to start on.
Yeah, so we can make a whole history sandwich here of kind of like what got my brain into proper, at least from what worked for me to stay hungry and continue to be incentivized and excited to learn and continue to basically do all the things that seem boring. Someone might look at computer programming and go, gosh, that's really boring. But it really is about making other systems more efficient. And it goes back to being an immigrant kid. When I was 9 years old in 1983, my dad was nice enough to scrape the pennies together from our account and get me a Commodore 64 to practice. And it was humble beginnings because we didn't have a hard drive or a disk drive, even a disk drive at that time, right? And so every time I would finish a program and it was time to go to sleep, I'd have to turn the power off, and that means everything you programmed is gone. And so I started writing down my programs on pieces of paper and come back from school, quickly type in everything I did the previous day, and then write some more, and both on the paper and on the computer, and rinse, repeat every day. Sounds crazy, but why would I continue with that? Well, it was really about being able to express myself and make a computer do something, and show the power of automation, that you could multiply your own ability, because the computer would take those instructions and multiply it. It's like a fireworks artist. You make place these small little fireworks, and then you have this huge creative thing that explodes and can be viewed by the city. So it's this I guess a lot of artists also have that, is that the small efforts that they have influence hundreds of people, bring pleasure to hundreds of people, help a lot of people. Yeah, it can be just an engineering endeavor. There's many aspects to it. I mean, you can have multiple solutions for the same problem, and that's, I guess, the artistic part, is which one do you choose? Is it aesthetics? Is it efficiency? You get to do that. But there's definitely a passion there for creativity and construction and engineering, making things, being a maker. So having no disk drive actually taught me how to type fast as a kid. At 9 years old, because it was infuriating coming home to start from zero every day, So so it's kind of, you have programming katas. People do the same problem. A programming kata is something that will teach you a concept. You can have katas for like React and whatever languages, Clojure, etc. You want to learn a language, there's these Git repos which will have a bunch of exercises that are small, kind of wax on, wax off, the type of exercises from Karate Kid, where if you just do them, you'll get the muscle memory and you'll really be proficient, right? So in a sense, I was kind of inadvertently creating my own katas by being, family being too poor to actually purchase a cassette deck back then that was viable, or a disk drive. Eventually I did get that, but by the time I was in grade 7 and grade 8, I was programming in assembler, because video games don't really work well in BASIC. It's very slow, so you really have to dig down deep, and I managed to find a book on assembler, a couple of really, Jim Butterfield's a really good book that I remember, on the 6510 processor, to learn all of that, and then also the reference manual for the Commodore 64 were kind of the only ways to really learn. Thank God there was the book, because everything else up to that point, that reference manual, was learning from a reference manual. There was really no examples. It was, this is the instruction, this is the instruction, and this is the inputs and outputs, and very dry, very there's nothing for you to learn, and all you can do is experiment. So it really taught another aspect of being able to interrogate a system and see the inputs and outputs to really understand what's going on in an empirical sense. If you're too young, like a kid trying to read an assembly book, right? So it's a lot of experimentation. You at least get the code that this thing represents, so you know that LDA is load accumulator, but what the hell's an accumulator? And you sort of say, oh, okay, well, this saves an instruction when you're trying to do these additions and whatever, so it's faster. I can use it here to make the video game faster. You start to put this stuff together yourself, which is really cool. And anyway, so eventually I was writing my own programs for word processing and all that kind of stuff by the time I got into grade 8, and I was consulting by the time I got out of high school. Got into the enterprise systems development world in the 90s, and I was kind of dismayed at what I saw. It was people get paid how much to do what? Double click the button and start typing the event handler in some Windows thing. I mean, it was great productivity, but the level of technical understanding was so low, and there was so many politics and the requirements. There's an entire world outside of programming above that I wasn't really experienced with, and it didn't really sit well with me. I guess I did what I was told and worked on these things. I was just happy to be paid for doing what I loved, sitting behind a computer typing programs, right? So that goal was achieved. That's awesome. But then you started to ask, well, is there more? Why are these things inefficient? I can do a better job at this. Why can't I do this? And start to do the ladder climb in an organization, which everyone knows is a tough thing to do. So trying to push things forward led me into Agile in 2000 and earlier, maybe around 2000. So as a really early adopter to Agile, simply because at least in those days, it was looked at XP and TDD, and it put coding back at the forefront of actually doing things. So things like test-driven development was like, hey, design comes from the developers. Cool. I'm a developer. I want to feel empowered. Let's actually have this design come from what I do. Again, that was short-sighted. And in 2008, I met a guy by the name of Greg Young. We just did the meetup with earlier, just before this. And in 2008, I managed to work across the street from him just by chance. And this guy turned the world upside down for me. He said, all this stuff that you see in the enterprise development, it's really, there's a lot of fluff there. And even the Agile stuff is more of a Band-Aid for a lot of things. Let's look at what systems are. And that I learned event sourcing and CQRS from the guy that came up with it. He ended up coining that term in Vancouver. Now you have LinkedIn and Netflix and all these really large companies using event sourcing and these ledger type storage for facts and events as the way they scale these really large organizations. I noticed that there's some truth out of these really intense. Greg was working at Wolverton, which was a securities trading company. They had gigabytes upon gigabytes of information per hour coming in from the TSX, and they had to react to this in real time. And really the only way they could make a system work was by using these event-driven architectures. But by boiling off the cruft, by needing to be accurate and performant and still perform a business task in these really intense situations, showed the true nature of information systems itself. Particle colliders and boiling things to high, we see this in science. We start to find out things when things are, pressed to their limits. You start to find out the core nature of that substance. And that's what happened to me for information systems. It was that aha moment that even after, a few years of doing that type of development, event sourcing and CQRS with Greg, I noticed that, wait a second, this is not just for these high intensity systems, these performant live trading systems and whatever else. I can use this for a startup. It's actually way better to talk about events and facts as a starting point for any system. I started to use the term information system instead of programming. I'm automating information systems. I'm not programming. Because people are saying, well, with programming, you have, encryption, you have all these other things. But 99% of programming is just your regular insurance company or your bank or another startup.
Moving data between systems, inputs and outputs.
Yeah, data from A to B. You got an API that your app is like interrogating to show something. It's really not that interesting, right? And it shouldn't be. I mean, in order to live our lives, we don't have to solve a very difficult algorithm or use a very difficult algorithm. Before computers, we weren't doing that. So our regular lives are still just information. So it makes sense that information system automation is boring and should be boring. And so by looking at this kind of, this new way of doing things, we were able to remove quite a bit of distraction with all these different vendors and languages and frameworks that kind of had this efficiency that you got sold, but you really gave up a lot for that. You were forced in a certain way of working at a certain scale. Whatever your frameworks are things you have to fit your solution into. And the benefit is that you get some performance out of it. Libraries have a slightly different bent where you have tools, you still have to orchestrate them. They still give you some efficiency, but you're more free to do them. So libraries and frameworks are helpful, but it's really important to understand what contexts they're helpful in and what you're giving up by using them. because nothing's for free. There's always a trade-off. And so what we were able to do is just look at, what is the dull roar? Like, can I do all this with standard libraries in the language? A lot of the time the answer was yes. And I looked at, well, if I was going to introduce a framework for something, what is it giving me in value? Should I do this? Should I at least do this without at first understand exactly and map exactly what the framework is being used for? Instead of trying to,
What I love of this paradigm is it kind of puts all of those framework and technology decisions away for a minute. You're like, let's not even talk about that. Let's start with what is the workflow or the user experience. And I think it could be the user experience when you're building a product for another user, right? Which is sort of how I think I came to understand it from the examples that you've shared. But we think about it a lot from the perspective even just of internal teams and the workflow that the team is doing. How are they changing the workflow to adopt event modeling? How can they even use event modeling to model out their experience of their workflow?
Yeah.
And when I thought about it like that, it really helped me to think about it in similar terms to something like value stream mapping. But I really love how much more practical this seems to be. And the modeling exercise, maybe we could unpack the workflow around event modeling, because
absolutely.
I think that gives people some like strong context of how you work with event modeling. What kind of tools do you use to help start that journey of going down the idea of, event modeling first and then tools second?
Yeah, so again, it goes back to that idea that there's a fundamental insight that we got about information systems, about input and output, and it leads to 2015 when I had to incorporate my own company, because this is the only way I really wanted to work. Every time being a consultant somewhere, I'm always fighting an uphill battle with the traditional management, etc., fighting the status quo that. Not everyone's on board to move things forward. So by starting the company, I could say, people like me, come here, we can do this together and really be good. And if there are clients that want to do things in an event sourced way, in this responsible way, get all the benefits of it, they at least have a company that will do that. Sort of the same way that ThoughtWorks excelled at being agile adopters. We're sort of the ThoughtWorks of event source systems, where we'll be able to take anyone, any company that wants to, and adopt an event-centric architecture and way of thinking about their information systems, not just from a technical perspective, but also from how that affects requirements, which really talked about, and UX, UI, all those things are related. And if you're thinking about an information system from the perspective of events happening over time, you need an adjustment to how you do your requirements. You need an adjustment to how you run your projects. You need an adjustment to a lot of things. Because, for example, if you do have an event source system with an actual plan of how you're going to do things, and an actual blueprint, you can do fixed cost pieces, and that's really hard to do. And we're able to do that. And so a lot of companies want to take advantage of that, but they need to understand that they have to change their way of thinking. So in 2017, 2018, 2-3 years into it, we finally got to push the envelope further as we were getting really good with, with only doing event sourcing. Because, as I said before, it was always a consulting kind of place where I was alone in the sea of other people that maybe some of them were interested. But now we had a company for 5 years going now, since September 5th, of basically doing only event source systems. We don't cut corners by just stuffing everything into a common set of tables. We're going to actually have an exposed log of what happened and derive everything from that. And because it affected requirements and things like that, we tried to find ways to look at that value stream mapping, user story mapping, etc. But nothing was quite right. And the first things that I did with Greg in 2008, or at least I witnessed him do this, was talking about these trades that had to happen based on market input, and he was just putting stickies across the whiteboard about what events happened on the timeline, like what are the price updates for certain securities that happened, or what happened in our system over time. And he could slice up time and explain to anyone in that trading company why those trades are being executed and how this algorithm is going to work. And that was a key insight, because that works for regular processes. If you're automating a diner, or you're automating a time tracking system, or anything like that, you can talk about what happened on a timeline and show that. The thing that we added, which was missing, This was a very back-end heavy system that Greg was working on. But in order to make it accessible for everyone, we added the UI on top. And even if it was a back-end system, that could be expressed with a dashboard that changes over time.
Do you have an example of that you can show us if you screen share? I know that there's
Yeah,
different tools.
I forgot we can share screens on this.
Yeah, bring us into the maps and the code, and just I think the visual support of just how you kind of model it out is very helpful.
Especially with what you're saying, like the visual just makes it so much easier for people to understand.
So I'll give you
and I think
an
that's the power of the timeline, right? Is you can visualize.
Yeah, the timeline is super fun. You know, I talked about a very small example of like this happens with regular systems already, like a diner. Actually, I still have this opened up. This is great. So.
And there's some great examples on your website too, eventmodeling.org
absolutely.
as well.
I do have that. So we can look at a traditional system and how we would capture the same thing. So as we go over time, we can start to dissect what goes on in the system. And we find a little bit of an insight into what's going on. Let me just see if I can share the screen here. And we'll look at that right away. If I can find it. Okay, there we go. So we start off with a screen. Let's say we just display an HTML page of a form to register. We know that we're registering, so we write down this event that we want to register. We don't actually write this down anywhere in the system. This happens in our brain. The actual piece that does happen over on the system is we have an insert statement into our user table. We then have a select statement to show the next screen and that information. And we continue to then have a verification emailer that sends out that code or that link that we have to click or whatever. But we can start to see how there's some coupling here. The interesting part about event sourcing is that these orange stickies we throw away. If we have a traditional architecture, the orange stickies are actually the truth. That is what the user experienced, right? User experience. This is what the user experienced. And that most important fact we threw away. We had some weird way of showing it. We salted and hashed the password, all the things we have to do, but we lost the meaning of what happened. It ended up being this dull, dry insert statement that updated some columns, right? Event sourcing is about using this as the source of truth. And so the website is about event modeling, but it's heavily based in the idea that state is king. And Fred Brooks talked about this back in the Mythical Man Month, where he said, you can show me all your clever algorithms, but I'll be mystified. Show me your tables and I'll understand what your system does. I can read the data in them. I can read the column names, and I'll understand more or less what your system does. We can take this to the next level by showing what events we have and what data they have. It can literally talk to us. And so why not put the cart before the horse and write our requirements that are going to map directly to how we're going to most responsibly implement the system. And so if you go to the event modeling site, obviously you can see the basic example of a to-do list and this nice sine wave of I want to add an item to my to-do list. It gets recorded as a fact. It updates my list of items that I display again, and I continue this sine wave of input and output, getting more and more feedback from the system. And this ends up being quite interesting, but 5% of everyone out there is doing event-driven systems. So we can't talk to regular people like this.
What biases do you think exist in how we think about information systems, which has so dominantly sent the market down these traditional approaches, and this is such a novel thing in how people, because I mean it makes perfect sense as you explain it and the way we think about these systems, but it's so much not the norm, right? It is contrary.
Yeah, this is a synopsis of the articles on the site, and the first article this made Hacker News top story back last year in maybe October or September or something like that. And we look at Moore's law as interpreted by storage, because at some point when we were the first 5 decades, we were getting computer systems to do what humans did, but it was very early days, and it was really expensive to store things. And the advent of the transistor, in terms of getting processing done much faster, there was never that transistor for storage. Storage was always still magnetic media. There was no equivalent of a transistor for storage. And so while we had this capability to process so much, we had nowhere to put it. Right? I mean, if we're doing things by pen and paper, we had a filing cabinet that kind of kept up with how fast we could fill out
forms. Back to your earlier analogies, right? And I love that because I think about my brain as RAM, right? I don't have much hard storage, but I'm always trying to increase my RAM and how much information I can hold up here. And where computers there's an ad is it increases that capacity, but also it has storage. So do you think the storage is the driving factor because we were trying to optimize really for storage on computer systems?
Yeah, I think this is the huge rise of RDBMS and having table storage and that normalization that we want. If we're going to store an address for a client, we're going to store it once and only once because, you know, at the advent of all this automation, a hard drive in the 1950s stored, 10 megabytes and cost $1 million, weighed a ton, was the size of a room, cost $30,000 to operate per month. And so if you told, your boss that we're going to have to store the old address for the client and their new address, and therefore you're going to have to buy a whole new extra hard drive, they're going to say, forget it, man, that's $1 million. We're not going to do that. So you need to link to that one table of customer addresses from these separate records.
It's interesting to think how sustained this thinking is in technology and how much faster technology has outpaced our human ability to recalibrate our thinking to the technology, right? And how much faster it's proceeding. Because, that certainly, if you were to rethink it from first principles today, storage would not be the thing. Like, you're like, S3, go for it, right?
So what we're doing is we're not teaching people here. We're actually helping people unlearn some of the crutches that kind of got sewn onto our sides as we went through the recent history. Like right now, my phone's got enough storage space to automate any insurance company, global insurance company from the 50s, right? It's impossible to comprehend that back in those days. So there was always, I don't think Bill Gates said this, but you'll never need more than 64K of RAM or whatever. I think it's made up. I think there's no, but these kinds of things that just ignored Moore's law and all sorts of other advances, and just really put a cap on, what people thought humanity was going to be capable of. It's kind of a ridiculous thing to do when we look at the long history of just continual improvement.
What kind of responses do you get from people as you're out there evangelizing this? Is it sort of like this makes sense, but I don't know how to implement it, or is it more like I don't get it kind of thing?
It's a lot of it's all over the place. But one thing I will say is that people from the business side appreciate it a lot more because they have the luxury of not being entrenched in the current tooling. And so when I talk about, I'm going to store the events of what happens in your business, and that's the truth, they go, well, of course. Why would you do anything
They don't
else?
have to worry about A to B. They're just thinking, let's do that. And I want everything. Give me it all.
Exactly.
Yeah.
So when you start looking at, and then also the fact that UX, UI, by example, human memory, the way our brains work, they work in stories. So I go into the first two sections are worth everything else in the article, because we go into how we're shaped into thinking that we don't have the capability to have stories implemented in our systems, to how our minds actually want to use stories to retain requirements and other things we talk about, designs in story form. And so we're stuck with UML and all these different things. I guess in event modeling was really the realization that I need a better set of requirements to use for these types of systems that are truer to the way that people naturally work. And everything else in the past has been made for that compromise of an RDBMS fully normalized one canonical model for the whole thing. The other problem is that businesses change. Humanity is fluid. We have better ideas, better abstractions 6 months down the road, 3 months down the road. And the problem with the traditional approach is that there was a static analysis of verb, noun, order, dot, complete, those types of things. And if business changed, we had to kind of scrap and analyze and how is everything working together again. That's not the right question. We don't have to think about how everything is working together again. We have to think of, how do I now record the proper facts that are now happening? And how do I map that small change in our understanding that happened this week to how we did things last week? And it's an incremental, iterative process where we continually map. We don't have a giant schema migration twice a year or once a year. We have a continual, responsible way of keeping up with our understanding that's hand in glove with the business, so that we can be truly agile, not just by having stand-ups and whatever.
I'm so sold. Let's do it. Let's jump into it. I know you have a ways to can we event model something right now and just go through that exercise?
Well, I can quickly run through the basic steps that you would do. So I mean, a complete model sort of looks like this. It looks like a sideways sequence diagram that's got UI built in, and it has example data and has no branching. If you want to run a workshop on it, you kind of there's a whole bunch of steps here. But let's say we're going to do something from the start.
Yeah.
We're going to do our own hotel. And so we'll brainstorm all the events that can happen in the hotel. People can check in, people can pay, people can get their room cleaned. What else can we come up with?
Do we prioritize that based on how we think about the value of the things they can do? Obviously, I need them to be able to come in and book a room.
We do brainstorming. Well, let's worry about that later.
Okay.
Let's just get the ideas out there.
Okay.
Let's be very creative.
Got it.
And really get things out of the corners of our mind and get them out on paper, right? And but then the next thing, we got to think of a story. Like what does the 1 year look like in the life of this thing? Let's say, okay, I think I got all my ideas out onto the table, and you think you got all your ideas out on the table as well. Can we now solve this jigsaw puzzle, throw away the extra pieces or discuss them, and actually make a story that makes sense? Oh yeah, people check in, people pay, people get their rooms cleaned, people order room service, anything that can happen in a hotel, right? Including emails about your trip's about to start, whatever it is. We can put it on here and on a timeline and by example. We can have Bob and Mary as two separate guests. We can have Joe, the manager, and I don't know who else. Adam, the janitor, right? That's sweeping the stuff, or and
Rob for room service,
or whatever. Absolutely.
Frank at the front desk.
Yeah, but essentially what we're doing is systems thinking. We're thinking about everything that we want to control, and we can brush aside things that we're going to hire a cleaning company, so we don't have to worry about these things. We can still show them in the diagram somewhere below, just as a reference. But what we're doing right now is talking about systems thinking. This is what we have scope over. This is what we can control. The next thing we do is we put the UI. Half the people out there are visual. You cannot. You can say, our system is entirely back-end. Like I said with Greg's trading system, even though it was in the back-end, it's good to have those screens that show the trade status or something that a user, even if it's an admin that's watching over, what is a visual representation of what's going on.
So quick pause,
even if we don't
in this workshop, you're bringing in the engineers, you're bringing in the designer, you're bringing in the business stakeholder, right?
Everyone.
And so this isn't catering at one person's personality, design-led thinking might.
No, we want everyone's.
You want everyone's.
So one of the. Yeah, exactly. We don't want this to be an ivory tower type of exercise where we have some product owners in isolation dreaming up, something to throw down onto the developers that will have to do that then. We want collaboration, because if you don't do that, you end up with 1,000 meetings after to explain yourself. You also get people that kind of like, well, I wasn't involved in this. This is kind of a dumb idea to do this. If someone showed me this earlier, I could have showed you a better way to do it, and I didn't have the opportunity. Now it's too late.
Can you do this in person as well as remote? Like, and what is your experience as far as the difference, right? Because obviously we've moved to this very remote centric world over the last 6 months, and that it seems to me that's one of those workshops where obviously in person environment drives a lot of this creative energy, but do you feel it's the same way as you move to online?
Yeah, there's definitely different dynamics at play, and of course there's advantages to being in person, but there's also disadvantages.
Right.
So some of the advantage of being in person is being able to talk face to face. Humans, when they talk, there's small twitch movements in your face to accommodate communication. This real-time response is even subconscious.
Right.
So the level of communication that even a camera has delay, you won't get that on a video call.
But more, it's like the sticky notes. Like in person, you're putting these sticky notes on a real board.
That's the other part. That's actually the
Online,
negative part.
Software tools or something.
Yeah, exactly. So that's the positive thing about in person is the fact that you're face to face with people, and you can accommodate more people because in online it's easy to interrupt people, and it's really hard to have more than two groups of people talk at the same time. It's just not built for it.
Yeah.
But in an in-person thing, you can have small clusters of people forming and dissolving and reforming and having these multiple conversations going at the same time, which is great. And like I said, the personal thing of being able to take cues off of people's faces makes it a lot more real. Mm-hmm. The bad part of it is that you're dealing with, if I need to have this event twice, I literally I can't Control-C, Control-V my sticky note. I have to write another one.
Right.
Right?
Yeah.
So there's just a physical problem. And then, of course, digitizing it after you're done with this exercise, we go all the way through and come up with
those are the 7 steps.
With our event model.
Yeah.
Now you're taking panoramic photos, and then someone's got to transcribe it, and because we use this as a blueprint for building the entire system, this is a really good understanding of what people see over time. We can hold it up against the light that this is actually happening. It's either happening or it isn't with our final product. So we have a very good set of done is done for like when we're finished with something. I can hold this up against the light and say this team actually did what they were asked, or they didn't, and they have to do this. We take this to the next level by moving these little pieces, these green stickies and these blue stickies, which is input and output. They actually make a real good counter for like how fast you are. And so if we have an event model, we can have an average of how long it takes us to do projects, and we can get a very fine-grained estimate that's quite accurate and give a fixed price cost for projects, which is really good because we can pass that fixed cost on to the people that are doing the work. If it's not doing what it says, you have to fix it for free. So if you try to go fast,
makes commitments
next week
really
you're
clear.
Fixing everything.
Yeah. Well, I know you had a really cool tool that you told me about that you use to manage this online. A tool that helps you with some of this diagramming. Let's dig into the tools a little bit, because I know that not only you have the visual tools, but I know that I've seen you tweeting about a lot of things about being able to interpret these into almost like programs and frameworks that helps you accelerate that delivery, and that's part of that fixed cost attribution, right?
Well, the clue lies in the fact that we see the same pattern over and over again. In fact, event modeling is really a combination of 2 core patterns for input and output, and 2 supporting patterns that are just basically input and output from subsystems instead of an end user. And so you can describe any complexity by stretching this out horizontally to express that, which will give you a proper estimate, because now you have that granular state change that you can sort of get an average for more better than you would if you just said this is a extra large t-shirt size if you're doing agile. This way you actually get to dive into what that detail is. And so if you have this sort of cadence, you can, because you have a set of patterns that are quite similar, the only thing that's really changing is the data. You can start to say, well, why don't I automate some of this? I can actually have a ton of this as boilerplate code that'll just get these things done. And actually, that's what we do. We started out with this approach, saying that each project almost looks like the previous one. This is great because we have predictability. If I'm automating one of these things, I can just copy paste the previous command handler and just change the data and the tests around it and all that, and it'll just work. I'm writing so much less code, but it's giving me so much value. And so taking that to the next level, as you have a digital version of this, you can.
Wow. This
is a time tracking application.
That one's really intense.
We're trying to actually shove a lot of things in here just to see how far we can take it before it breaks. But at the core, it's really logging time. I want to log time for working at Walmart, and these are my hours for the previous day and earlier today. And when I submit this next piece of time, it just gets written as this event, and then it updates this view of what my hours are, and that just gets displayed again as we go through time. We see how we progress. That's all it is, really. In here we have swim lanes for subsystems, so you have client management, user registration, time management.
So when you started this, you were manually creating these diagrams, I would assume, like on paper or large whiteboards. Is that sort of how this started out?
This one was already past COVID, so we started this at the online using Miro, which is a popular virtual whiteboard with collaboration. But unbeknownst to me, people have taken up event modeling and have built entire tools for it. So here it is.
Cool.
O-Note came out of the blue. And it has all the opinions that you need. Events can only go to the green ones. The orange can only go to green. Blue can only go to the orange. So it has all the patterns built in, so you don't make a mistake. And it's a simple drag and drop. And the best yet here is that up here we have generate code.
Oh, cool.
What do you know?
So what would that generate? Would that generate
that'll
source
generate
code or?
Yeah, it'll literally give you the scaffolding that will move you through your workflow that you showed by example. Imagine this actually going through with AI, looking at all the different code committed to GitHub and intelligently knowing that, hey, over here, it looks like you're trying to approve an insurance policy. This is the type of code that needs to go here, and we'll do the translation so that the variables make sense and all that. So, programming is becoming the bricklayer type of job, and it's not that it's going away. It's just that you won't need a 50-person team to automate your system. You'll need 2 or 3 people when a lot of this type of tooling is available to you.
Yeah.
So
systems are going to get better at doing the heavy lifting of the business logic, the inputs and the outputs. They're going to become more context aware. So diagramming, system architecture, system thinking is where the evolution is kind of heading.
Yeah. You're describing information system workflow by example. This is BDD, behavior-driven development specification by example, done for an entire system, essentially. And so by having enough examples, as you know, with AI, you could infer what the statements could be, not even just by analyzing the data, but also just by mapping it to other open source solutions that are out there and just taking that same logic. And the only thing is, if you show an AI system enough examples, it'll make the thing you want, right? That's the promise of AI. So what better way to show what your system's supposed to do than a movie-like storyboard with a script and a set of keyframes in it with actual example data? You can't show a better specification than this. And that's why you can automate this to actually give you the system that you want.
Super cool. Have you done that?
So,
have you taken this JSON, this XML, UML, or whatever that it looks like it's JSON, and actually
it'll export JSON,
consumed it in code and been able to leverage it?
No, we haven't. This is something that we're exploring in our meetup all the time. Evidence Systems spun off this O-Note program, so we're working on actually getting a standard that's an event model. It's not going to be anything more special than HTTP standard or whatever. It's supposed to be open and for the community to really use and continue to use for building systems. So it should encapsulate the fact that an event can only go to a view.
So once there's a standard, then we can talk about how we consume this at scale to make
exactly.
more.
So then everyone kind of is talking the same language, just like everyone knows that you send email a certain way. Everyone knows that HTTP is a certain protocol. Those are things that move things. Those are standards that move the industry forward. So what we're doing is the same thing for specification by example. To be able to do that. So event modeling is that. We have, I'm working on the book. We have a ton of workshops on this. There's lots of ways to learn about it, but really the tooling will help quite a lot because if you're just looking at a blank Miro board, I'm just going to cancel that for now. But if you start with a blank Miro board, you're going to be like, well, what do I start? How do I draw these, swim lanes, etc. But if you open up O-Note and it says, oh, okay, interfaces are up here. Cool. So I can add swim lanes for, each of the actors and what they're seeing. Up here, I can move this up and this can be what the actual.
Do you see a bridge to something like Open API, at least for the backend systems, being a way to...
Yeah, of course. It's really independent of the implementation. So, what you're talking about is information flow here. Right. What we're doing is we're showing just how, as you slice time very, very thinly, we can see what each single state transition is and how each view of those events gets updated. We can show eventual consistency problems. We have a distributed system. Oh, this thing didn't make it across the Atlantic yet, so this person's seeing this old information. We can show how stale things are for certain people. Whatever you need, you have this ability to slice time kind of like a sausage, because if you think of systems thinking, it's a rectangle, and it's a way to statically show what you're in control of and how it's made up. But now that's a dynamic thing. There's data moving in it. So if you just start to move it through time, through space, I mean, to simulate time, you notice it's drawing different patterns, and it's kind of making the sausage. You know how sausage has the white bits in it and the red bits? If you slice it nice and thin, you can see the pattern slowly change, right? So we're kind of like slicing up the sausage of your system as it moves through time.
Now I'm hungry.
Yeah, this seems like a future challenge for you, Adam, in one of your meetups.
Yeah, how thin can you slice the sausage? So the idea is that you should be able to slice the sausage so thin that you can isolate one thing happening, even if your system allows parallel processing, because one CPU cycle will win over the next, right?
I love it.
Always make the case, right? So you should always be able to slice your system sausage into explaining one thing changing at a time and why. Even though it could be arbitrary which slice happens first, you can still talk about it, right? And we mark that up. I'll show that here. Some of the SLAs we can show as like, hey, this is within 2 seconds. If I don't see the next screen after I submit my time, it's got to be within 2 seconds, or it's just people are not going to use it.
Well, I really like that, because that's similar to how some of the thinking in value stream mapping is where it's less about the context of the steps and it's more about where the weights. Because one of the things that Steve Pereira, the value stream guy from Visible, is talked about in his podcast was, the cost of automation is non-trivial, and just like the cost of building systems is non-trivial. And a lot of times, us as programmers, we want to automate all of it. And really, most things are not worth automating. But when you can actually measure that sort of time and weight scenario within these kinds of design thinking, now you start getting the truth of what a diminishing return looks like in incremental components of the system. And you can start making these really good decisions about, how important this piece is versus this piece, what should be automated here versus what should be automated there. And where those systems may actually add efficiency to the broader, or those subsystems will add efficiency to the broader system, right?
Yeah, I mean the example is I want that sales report, to be up to date to the half a millisecond. It's when do you look at it? I was I print it over the weekend.
Every week.
Really? So I've made this to consistent to the half a second where you really didn't care, and my SLA could have been 2 hours, and it would have made no difference. Yet I spent all week coding for nothing. Right, so it's about having because there's speed of light is our limit and things like this, speed of information, at least if you follow quantum entanglement, but whatever.
we see this a lot. We see this a lot, right? Because in our business, because we're focusing on the developer workflow, how do we automate things that enable efficiency for development teams cross-functionally or individually, or however you want to think about it. There's sort of this insular drive within DevOps of automate all the things, and a lot of times it just happens. So I don't know if this is possible, but I'd love to put out the challenge of maybe coming to one of your meetups and trying to event model out what the optimal developer experiences is, and just have some of those interesting conversations about where do we actually see ROI for ourselves, when we point this idea of event modeling our workflow and understanding how we interact with these systems. Because if we can make ourselves more efficient, certainly then the systems we build would become more efficient. And hopefully that could be an interesting archetype for one of the exercises you would run in the meetup. Absolutely, yeah. I mean, we're always looking for more examples to work with people on. It shouldn't just be my ideas.
So the door is always open to have different problems to solve together.
We'll open source that, right? We can open source a model for that and say here's what GitHub flow looks like, or here's what Git flow looks like. Here's the
exactly. I just wanted to bring to your attention the fact that you can do polyglot with this, because we have a really good way of isolating pieces of functionality. That these are contracts that are quite strong, because I know what events are stored before I get to quote unquote my slice that I'm working on, and what I'm responsible to leave for anyone else working on anything subsequent. If I do what it says, then things should click like Lego pieces. And not only that, it removes that rework piece of the agile TDD mindset that I have to refactor everything every time I add another piece. That just drives the complexity up and up and up. And the more code you have, the more you have to refactor. So the fact that this gives a scope to the refactoring part for TDD allows you to have these vertical slices as highly replaceable, because no matter when you're implementing them, will cost the same amount of effort. If you're doing it at the beginning of the project, it'll cost the same amount of time as if you're doing it 6 months later, because you have a reservation for where all the data is going to go. You have a very clear contract of how that data is changing. So this gives you open-close principle out of the box. And that's really good for polyglot development, because that
expand on polyglot, because I'm not sure that everyone of our listeners would know what polyglot is or what the benefits of it might be.
Yeah, so let's say you're running a company that does trading, and you have a master trader that comes in for an interview that knows all about all sorts of automated systems trading, but your team is Java and this person's Ruby. So you send them on their way because, well, sorry, our systems are all written in Java. We can't use your talents here. That's a horrible proposition. You just kicked out someone that had,
especially when people are struggling to find talent
exactly, and you allowed a trivial technical detail really to get in the way of you hiring that really good person. So because these slices are highly replaceable and they have a fixed cost and they have follow open-close principle, we can have a scheme like this where we have certain slices that take care of maybe registration, listing users, logging in, logging out. Maybe that's just a traditional .NET, and we'll denote those with this little mushroom from Mario. And this is just for fun in our meetup. We don't actually do this with clients. And Mario himself will be .NET, Linux based .NET. That'll be doing the actual adding time and modifying time entries. And then invoicing and timesheet reports will be Golang. We have a Golang person. And every slice that they build is going to be used using Golang. And all of these stacks exist in a Docker container. All we need to do is have Nginx point the requests to the proper Docker container. We share an event store, like those JSON objects that are the events. All of them can see that, so that's how we integrate state together. We kind of don't want to rewrite some HTML, so we can actually do views and maybe menus and things like that we want to share across multiple pages. Maybe we'll have a common standard for that and just interpret them. I know Mustache type of templates for Golang are popular there. Maybe we can translate into something else from .NET, but at least we have one place. So there's a bunch of stuff we can share here, but the actual business logic, where we actually do the automation can change depending on who it is. So here we can have some one part that's done in PHP even. So, what does that look like? Let me just stop the sharing and open.
What would also be the argument against that, right? Because I think one of the things that I've heard in that narrative that kind of emerges in practical sense is as you start having these different flavors of subsystems, you sort of take on the additional overhead of not having some level of consistency. But I mean, is that a verified or valid argument from your view? I mean, what other kinds of things would you hear? Because certainly the hiring argument makes a ton of sense to me, but I think part of this argument drives into this problem of cost of ownership, and I think that's a real tangible issue in some teams who spread themselves too wide across different technology tools, because you get certain opinionated techniques that emerge within this where if the commitment isn't strong, in the open close principle, there can actually be a really huge inflation from having such a diversity of technology, right?
Yeah, and I think this goes to the fact that if you're not doing an event model, then you can't afford to do that, because you're going to need to crack open the OCP, right? We have an example in the article about that, and basically it means if you have to crack open things you've already written, then you can't afford to have too many different stacks together.
Right.
The premise is that with an event model, there's no reason for you to be maintaining or adjusting a single slice. A change in the event model means replacing an entire slice. So if all of a sudden the way that you handle registration is different, the premise is that registration piece is small enough to throw away and just re-implement with the
I
new
love
one.
that. I've said
so
that
now
before.
It doesn't matter.
That's the perfect MVP.
So now it doesn't matter.
Can rewrite it in
exactly.
a sprint.
So, absolutely. So it's having that granularity so that nothing is too onerous to have to replace, and it's the most responsible thing to do. That's kind of explained in this part of the article here. Let me do that. I scrolled down too far. Let's see. Back to blog.
And I don't think we can see your screen anymore.
I'm just trying to get there before I share it. Yeah, let me see if I can do that. Chat. We have too many windows open.
Brings up his Vault key store.
Yeah, I never show passwords, but where did that go? That's interesting. Okay. I don't think the Zoom has updated what I'm actually seeing.
It's okay. If there's source code you want to show,
here it is.
maybe what we can do also is link to it afterwards.
Yeah, of course. So back to this article. This is actually showing that in practice. If we start to do a registration, we insert something in a table, then we have thank you for registering, your confirmation page. And then we start to write about the verification emailer. We have this extra code. This extra feature of verifying your email requires an extra field in this table. That cracks open the previous insert statement in the previous piece. Mm-hmm. This is where that coupling comes in. So what the event model does is we start with a complete reservation of where all the data is going to be. That's called data completeness, that you understand where the data is coming from, where it's going to, and you have appropriate places. That's what's going to enable you to have OCP. Because right now what we've had to do is crack open the code to make accommodations for this extra field in a piece of workflow that we already finished. Well, that's against open close principle. And now if that was done in a different language, then you were forced to go find that person to help you. If it's done, if it's going to be entirely replaced, or I just don't have to look at it because I already made the accommodation, then I don't have to crack it open. Mm-hmm. So this open close principle is really important because it eliminates rework. Because as the system gets bigger and bigger, more and more things you have to crack open if you didn't make accommodations for them. So this is small design up front, really. What we've done is we've taken the idea that you need all this UML, et cetera, to design systems and shrunk it down to like, no, you don't. You don't need to know the how. You just need to know what people see and what the state is all along the way. That'll give you the reservation for everything. And that's light enough to give you architecture, especially information architecture, so that you know where things go. And you don't have to start to, move aside all the solid principles you've been taught, because open close principle is the first thing that goes out the window when you're doing agile and test-driven development. Yeah. There's no boundary, there's no scope on how many things you have to refactor every time you hit that refactor part of the loop. And what we want to do is definitely contain that, and by containing that, we get the flat cost curve.
Right.
So it doesn't matter if I do A first or G first.
Yeah.
it all costs the same, right?
So the premise is like you
yeah.
may not be able to avoid rework because you don't have a crystal ball in the future, but look as far ahead as you can to minimize it and mitigate that.
Exactly.
Proactively.
I mean, how you change, doing change management with these types of systems, you basically say, okay, we have more information about better requirements. When you just look at one event model versus the next, at least you know which slices you're going to have to change, which slices haven't been done yet, so those changes are free because you haven't implemented yet. But you have a really, really solid, no pun intended, change management system that gives you a clear scope and cost of what introducing a different way of working halfway through a project is going to be, right? What it's going to involve, which parts are going to change, which parts are done, which parts aren't, and how that affects your timelines and how that affects your budget, both. So it's quite powerful. I'm not sure what else to go in here, but yeah, that's about it for this.
Well, I actually think that's an amazing overview of everything that you've been working on and how people can kind of get started with these concepts.
Yeah, it's a lot of fun because in terms of how someone said TDD is really a good way to get some sort of a cadence of how to start because you're just doing dumb little tests, one a little bit more complex than the next, and it gives you guidance. This is better because it gives you guidance of following the line of where the information goes. So you can follow these little contracts to just say, okay, if I'm doing this, this particular piece here of logging time, what do I need to do? Okay, well, I know I have to draw this kind of UI, then I have to have a button with an event handler there, and I submit some sort of command conceptually or an actual object. I don't care. It's independent of my implementation. But in the end, I have this little event that gets stored. That's my success criteria. From here, I can follow the lines. Like, okay, well, what does this thing feed into? Oh, it feeds into this report that's used on, in this case, the same screen. It feeds back. It's a self-posting page. But I can see exactly where to go next. And as I fill this in, I just keep coloring in. And when the whole thing's colored in, I'm finished. It's an incredible guide for where to go next, where a lot of programmers are like, am I going to get stuck in the infrastructure code? Yeah. Should I gold plate this before moving on? Here you can get your information right. Yeah. Let that be the backbone of your system. And then you can start to look at, where some improvements need to be and ask. But holy smokes, you got the backbone of the system, which is the information actually getting transformed the way you want. Yeah. Now you can throw it against all sorts of different frameworks, libraries, any other helpers, but you got the state right. That's where the bugs are. You got the state right. No more bugs. Now you're just making it more efficient. And that's way better. I mean, this is, if I take the core part of this and I show my boss that this part's working, they're like, great, now get rid of the boring parts like logging in, right, and registering. I can start right in the middle and say, look, boss, I got this time tracking thing to work. It shows me the reports, and we can have an admin say yes to this.
You can demo it.
Sheet.
Now you can demo it and
yeah, you can demo it exactly. So what we do, for example, if I got this part here done, right, I can leave out the fact that I'm logging in. I can put in a fake event called logged in. I just shove it in, just as on the disk. I'm logged in. Who cares? When the code runs from this point, it's as if I'm actually logged in. When I get to the logging in functionality, I replace my fake event with the actual login screen that actually produces that event. And things tick, they work like clockwork. Those gears just snap together, and I have the system. But I showed the core concept. This is agile, right? This is your MVP. This is all that stuff that you want immediately. You don't want that zero iteration of setting up your all the things for builds and making all sorts of getting ready to get ready meetings. You just go. As soon as you have the event model, you're like, here are the state transitions. Here are the first screens working. That's our core. Our core is bringing business value. Our core is not sinking time into the cost centers. Our core is getting this right because this is what the boss is talking about. He's not talking about whether you're using tabs or spaces. He's not talking about that stuff, right?
Woo! Woo! Preach, man. That's a good one. Wow.
It just wants this done. So show him.
Yeah, love it.
Well, Adam, as we move to wrapping up, I know you use a bunch of interesting open source tools. Tell us a little about your tech stack, your favorite dev tools. Give us a rapid fire drop of some of the things that you enjoy using.
Yeah, I wonder if I have any incriminating stuff that I can share my whole screen here. I do have. I guess I can just do that. So I have a ton of. I'm an open source geek and nerd, and I love Linux. So I'm running on Kubuntu most of the time. I have one mate install and a few other Linux flavors, but for the most part, I'm 100% Kubuntu now on everything. Although there's, I'd like to go for a rolling distro maybe or something like that in the future. For now, it's if I share the screen and let's see, that's fine. Any other time?
Don't worry, we'll blur it out later.
Can you blur this out? Share this desktop. Okay, so my favorite IDEs are obviously JetBrains because the navigation, in the background AST is incredibly powerful just to be able to refactor things very quickly. It's always been a core thing. For recording, I'm using Audacity, LibreOffice for all of my office needs. I use Nextcloud for sharing documents in our company. We use Rocket Chat as an open source. We self-host everything, so we have a love-hate relationship with the cloud. We really want to own our data, so we have our own cloud a lot of times. Like I said, obviously Steam for games on Linux, GIMP for a lot of the stuff to basically draw things, Blender as well for OBS, which you guys use.
Yep.
Krita for painting. I was drawing some stuff in the previous meetup. Let's see if I can actually get at it here.
I love your toolbar. It's been a while since I've worked on Linux as my day-to-day.
Yeah, it's really cool how the theme permeates everything. So if I open up Inkscape, let's see how many things I can open up before I crash. I hope
Linux, what Mac OS could have been, right? This is what it wasn't this way back in the day when we were dealing. Well, maybe it still isn't when we were dealing with Xorg and all of this, but yeah.
Well, one of the nice things is that, the reason I'm using JetBrains stuff is because they brought .NET to Linux, right, with all the refactoring. So I love the fact that I can do C#, which I have a lot of experience in, on Linux, and it just works. So my example here was in C#, but it's all running on Linux, and that's great. And so Krita is, what I use. I have, if I stop sharing, I can show you the awesome tablet that I use, but maybe I'll move it back.
Yeah, I was going to say, it doesn't look like you were drawing that with your mouse.
There we go.
Yeah, exactly.
Okay.
So,
Nice.
If I stop this, this is kind of the awesome tablet, which allows you to have...
I love this. It's like a behind the scenes.
Pressure.
Yeah. The hardware and the software.
Don't mind the messy room.
No.
This is my office.
CTO.ai ops show, moving to a cribs near you.
Yeah, I love art, right? So I draw if I have time, and obviously for my book I'm doing illustrations. But this is a tilt pen and has pressure sensitivity, and this tablet works as a screen, so you can see what you're drawing, not just that to be to the side. And it's actually better than it's the same as a Wacom tablet, and the Wacom tablets are kind of like the Apple of tablets. They pay for the name. But this Huion thing is awesome. It's Huion, and it just it's half the price with the same specs. It works on Linux. Awesome for art nerds like me that want to draw some stuff. So let's see what else I can show. There's a ton. I use KeyPass for. I stopped sharing my screen. Here we go. Share screen. There we go. Share that. So yeah, KeyPass for my password manager. That I sync across phone, all computers using Nextcloud. Nextcloud has really good sharing. If I can just open up Nextcloud, where are we here? That's notifications. Somewhere in here. Anyway, it might be on here. It runs in the background. Let's see if it pops up.
So this is what you said for your private cloud stuff, to keep all of your data private?
Yeah, basically, we run on a dedicated giant server in Montreal, and then have everything Dockerized in there, including Rocket Chat, Nextcloud. Our email is even done there, so we dropped Google. So we really are, eating our dog food in terms of talking about decentralization and not giving all the power to the really large companies.
Mm-hmm.
So we've had better uptime than GitHub and everything else. We use Git for source code control and their private repos. Git is absolutely fantastic. We've had what's it called? A lot of outages with in GitHub. We haven't had any in our own Git. We've tried GitLab, at least I did, but it was just so bulky that our DigitalOcean droplet at the time, which we were using, just the basic droplet wouldn't even run, because GitLab is just this huge Ruby on Rails thing that, doing a simple Git push was like 10 seconds. I'm like, oh my God, how many CPUs do I need to throw at this thing to actually make it work? And then at the time it was just GOGS. Git got forked from GOGS. I spun that up, put it on there instead. $5 DigitalOcean droplet. Took 50 megabytes of RAM, and you hit enter and it was done. Like, it was just, it's written in Go. It's super light and slim. There's a good comparison that they had. I tweeted it a while back, and there's a good comparison of all the features between GitLab, Git, hosted, not hosted, blah, 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 all those sorts of things. And so they're pretty much on par. But because Git runs so much faster, so much better with such few resources, that I'm like, there's no way that I can get out of using that. So I know you guys do a lot of automation, and hopefully you'll be using the Git hooks to include Git in your stuff, and that's a really awesome project, because it's kind of an underdog, but it really deserves attention for how much they were able to do with a really small team.
It's awesome.
And I love the fact that it runs on small hardware, right? You got to think about the third world, where people can't afford to have a large server somewhere. They literally are running on the laptop you threw out 5 years ago. And so when people say, "Oh, just use this and don't worry about the resources," it's cheap to buy a hard drive, it's cheap to buy a new processor. Well, not for everyone, right? We may be privileged here in the Western world, but elsewhere, in poorer parts of India, Africa, anywhere else, you're really not giving the equal opportunity. And we are globally connected via email and on the internet. And so I'm very aware. And of course, given how I started, I'm very sensitive to those things. I will never forget where I came from. And so every time I find something that uses things more efficiently, does things in a way that's more open and inclusive, I'm always going to favor those. And I think as a business owner, I have a really big responsibility to lead by example and show a working business while adhering to better ways of being a responsible citizen, right? And so that's I hope all this kind of stuff that I'm showing you here kind of makes sense where I'm getting the ideas for running on stuff like this, right?
Well, that's what this show's about. It's about not just digging into your workflow and getting those great recommendations. It's about talking about the 10x engineering philosophy, which we think is not one person who's 10 times better than everyone else, 5 people who make one person who makes 5 people 2 times more productive. And a big part of that is accessibility to quality tools, which is why we try to dig into it. So I think that's
I have one more that I'll show you that's really cool. That's gonna kind of that's gonna not be easy for a lot of people, especially if you're in the ops space, to do, but I just got so addicted to this, so I have to show you what this is.
Cool.
If I can get to the right thing. Yes. Okay. So this is my command line, and what I love is fish shell.
Oh, fish!
SSH.
Yeah.
Yes.
You are on the bleeding edge.
Well, it's version 3 now, so it's not really that. Oops. It's got it. Oops. I should just CD that. But if you like, a nice power line kind of interface. That's great. You can do this with almost anything these days, but this is one of the first ones that I had. I'm not sure if I had anything like this, but if you do like for file in, I guess you can do ls, something like that. And then you hit enter. Notice that it just indents you right away, and then you can just echo file.
So it's a REPL right out of the gate for you. It's interactive.
But look at this. I hit up arrow and doesn't mangle it like Bash does.
Yeah.
And I can start to edit whatever I want in here. And these little, attention to detail is so awesome. I know it's not POSIX standard, so you can't like really do your Bash stuff in here. I can just call Bash in whatever Bash script I want. Fine. But like for just being on the command line to like do stuff like this, I'm so much more inclined to just do an in-place script to do something on the command line, because fish is like butter. It's just so good because you go up arrow and it just works. I did an entire fish one-liner, quote unquote, to show all CQRS and event sourcing by doing a Trello implementation. It's a gist that I tweeted about. I can show you if you like. But it's it's essentially a giant one-liner that just shows you, here's some dots directory that I create in your home folder, and it has an events subfolder, and everything you do in your Trello board actually gets gets an extra file in that events folder, and everything you do in it just reads that events folder, and you can have event sourcing right on your command line without running anything. And a lot of people say that, event sourcing is so complex. I'm like, no, here's a one-liner that does it. It's not. The implementation is a separate thing, and I think a lot of people confuse event-driven architectures with really large infrastructural things you find at like LinkedIn and Netflix, right? And that's not the truth. The truth is that it's just looking at information in a different way. So, I like Hugo as well. So my site's done in Hugo. I like static site generators. So Hugo's really cool. Another Go project that is, again, tiny, lightweight. To generate a site, it's like instantaneous, super performant. In Netlify and Forestry can give you like a CMS like interface to edit them, and Netlify will host them and build them for you. Hooks up to whatever GitHub or whatever you have very easily. So there's a ton of like, those are some other tools. I can go on for like days talking about what I use. There's so many cool things that I'm never prepared to like show everything. KDE Connect for like my KDE desktop. Like if I want to send a file, it goes to my phone, no problem. Vice versa. Shared clipboard between my phone. It pauses my music on my computer when a phone call comes in. All this stuff that you think you could only get by getting something from a large vendor, it just works as an open source thing, which is so cool. So I'm a big user of the Linux desktop, and there's so many things that people don't know about that you can do. So many things that are just configurable with a settings tab. It's not the command line hell that people think it is. So especially if you've got old computers, don't throw them out. Just stick a Linux distro on there and like give it to your kids. It'll have a whole new life on there very easily.
Yeah.
So
I love it, Adam. I love your energy for the world of open source and how you really live and breathe it.
Yeah, thanks, man. We'll
have to have a whole nother show just for the rest of the tools you love.
Yeah, I'm a big, shout out to the guys at Jupiter Broadcasting and the other podcasters in the Linux space. They do the real hard work of bringing all the secrets of open source out to the open. So I'm a big fan of all those guys, and I just don't. If I had time, I'd do a Linux one too, right? Like a podcast or like a meetup. I did run one for a little bit. It was just in person. It might be better to have one online, but I have so much work for me just with event sourcing now that and event modeling that I simply can't spread myself too thin. So I got to finish the book for event modeling. Event modeling is now part of the UVic curriculum, CS 375. If you're going to UVic, you're gonna learn event modeling starting this term. And then more and more colleges and universities hopefully will adopt it with their software design courses. I'm hoping it actually makes it into the 200 level courses, so that it's offered at colleges, right? There's not many colleges that offer third year, for transfer. So perhaps we'll see a time when even gets to the level 100 courses, which would be my goal, and then ultimately, if possible, teach it in high school. Damn it! But no, it's nice to see that the university reached out to me. We're finalizing the curriculum tomorrow. It'll be part of that. So, and I have a whole new generation of people that are just not going to have to only think about UML when it comes to design. They're going to be able to talk about stories and these event modeling canvases and explain to anyone what their system's doing. Really track where they're at with their programming. Hopefully, it'll get new programmers to not be so afraid of where to start. Right? They can see that whatever they do, it does fit on the map, and as they continue to fill in the map, they get a sense of how productive they are. And the sooner you get that feeling, the more happy you'll be as a programmer. And so if you can do it at the university level, I think it's great. So we'll do that. I'll continue to do that. I'm just going to have guest lectures there, I think once a term for the next foreseeable future at UVic. And then I'll start to look and see who else wants to do that. Especially once the book is out, we can probably do a lot more than just being part of a computer systems design course. I'm sure it'll be something that can be done for requirements and other things that we're going to do. Yeah.
You're a busy man.
Well, looking forward to it. I'm going to drop all the links and all the tools and shout everything out in the bio. Remember, I think that's about a wrap for today. So
yeah, you want to show
again.
The resources page where people can find more information just quickly? I can do that as the last thing. So on event modeling, there is a resources page at the end where we have a Slack channel. So eventmodeling.org has a resources thing. There's Slack group, a bunch of videos we recorded for a bunch of things. There's the Golang thing that we did. Another example. Some introductory things. When our workshops are. Some of that little example, like the little gist I was talking about, the Trello board example that's in Fish Shell. I have a link to it here. So yeah, you can check it out here. And laptop stickers. Oh, I also forgot. I got new laptop stickers too. So they're Breaking Bad style, like in the background. If you want some of these, I'll send them to you.
We'll drop a link into the Slack group and try to drive some people over to your Slack group because I know it's growing and you're getting a lot of interest in what you're doing.
Yeah, I'm happy to help anyone on their journey of designing better systems. So thanks again for this opportunity to share with everyone, and I hope we work on some stuff together in what you're doing. With
Challenge accepted. I love it. Yeah.
And have a follow-up with what we come up with.
Let's do it.
That's great.
Thanks, guys.
Yeah, thank you so much, Adam. We appreciate it. We'll wrap up the Op Show now, and just remember, you can always subscribe by clicking the link in the bio as well to never miss a weekly show. Thank you again, Adam, and that's it. Take us out, Kyle.
Thank you.